My name is Kevin Yager. I'm a materials scientist here in the Center for Functional Nanomaterials. My research involves two main areas, one of making materials using self-assembly and one of measuring materials using X-ray scattering. And what X-ray scattering is essentially taking a highly collimated X-ray beam and passing it through a sample of interest and looking at the deflection of the X-rays as a function of angle to try and deduce what the structure in your sample was. One example of a project here in the CFN where we used both small angle and wide angle X-ray scattering was a solar cell project. We were looking at organic photovoltaic materials, which essentially are solar cell materials made out of polymers rather than something inorganic like silicon. X-ray scattering is an extremely powerful technique. So you see these interesting peaks or rings and patterns that come from diffraction and scattering events in your sample. What the user typically wants to know, what the scientist wants to know, is what is the real space structure. To back that out, to go from the scattering pattern to the real space structure is quite complicated. To do it in practice, we develop a number of theoretical models that we use to fit the data. And that can be quite difficult, and that's one of the ways in which I and the CFN more generally helps users achieve their scientific goals. We help them analyze their data using the correct model and even developing new models as needed to analyze more difficult data sets. So because we're doing research here, fundamental research really at the edge of what is known, every day that I come into the lab and do some work, it's in some sense work that's never been done before, work that's challenging, complicated, and entirely new.